Hello. Good evening, my dear JEE 2026 warriors. It's time to go to the next class of ray optics. It's a big unit, so multiple lectures in detail. Rather than finishing off, the entire topic in 2 hours or 3 hours, we are going systematically in detail. So, my dear warriors, show your full support, like the video, and subscribe to the Vedantu J English channel. So today we are going to do exclusive content on combination of lenses, whether they are in contact or separated by some distance, and silvering of mirrors. Both these things in today's lecture. Okay, so get ready for it and make sure you are liking and subscribing to your channel, my dear warriors. This is your Captain Shreyas. I have been teaching, mentoring, guiding for the past 13 years. I've been doing this. Whatever you are seeing for the first time, I've been doing it repeatedly. So just follow the advice, just follow the lectures. I will take you there wherever you are dreaming. Okay. So I hope you have also seen that particular news that MVSAT is now online. Yes, offline is over. We had a very massive successful event, and now only for those people who missed the offline or were not able to visit the center, or you are not in that city, then we are conducting MVSAT exam online. So make sure you're registering for it. Lots of prizes, scholarships, free study material, even on registration. And when you give the exam, a detailed report card, and you know where you stand among lack of students. So the link is there down in the description box of this particular video. As you can see, yeah, if you go down MVSAT, please register for it, and it will take you to the website. All the details are there. The syllabus depends on the grade and category which you select. Enter your mobile number, you will get a OTP, and you are done with the registration. The exam will be conducted on 21st to 29th of October. Okay, that is the online examination dates. Cool. So let's begin with the class. And hi Kevin, hi Kian, hi Kaguya, good evening Shivani, hello. Hello everyone. I'll confirm right, sir, eagerly waiting. I'm pretty sure. Yes, welcome everyone, all new kids out here. Yeah. So let's start with the concept of combination of lenses. Now, what happens is you will see that even your eye is a kind of a combination of lens, or even your cameras, mobile camera, telescopes. Multiple lenses are arranged one after the other. As a result, they can magnify it more or diminish it more, or they might have some purpose sometimes which is not possible using a single lens. So whenever two or more lenses which are absolutely thin and they are close to each other, they behave like one single effective lens. Like the one over here, the object is here, the rays are going in different directions. It will refract through the first lens, refract through the second lens, and finally forms the image over here. What if I tell you I don't need both these lenses? In fact, I can just take one single lens, which I now call it as my effective lens, such that if I place my object at the exact same place where it is placed over here, it will form the image exactly at the same place. That means the rays will refract exactly the way they are in this combination. Okay, so that is basically your effective lens. This effective lens will also have a focal length, and it so happens that the powers of all the lenses in contact, P1 plus P2 plus P3, like that till Pn, will be the effective power of that effective lens. The sum of the individual powers, not focal length powers, is the effective power. That also means 1 by f1 plus 1 by f2. Like that, you can go till 1 by fn will be nothing but 1 by f effective. This is the main formula of this particular theory. Okay, the powers get added and their focal length reciprocals will get added up. Okay, so let's solve some questions coming up on your screen. Let's solve some questions. Imagine I tell you there are two lenses, or let's say the following lenses of powers 2 diopters, 3 diopters, and 5 diopters have an effective. In fact, some of the powers can also be negative, guys. So say for example, we have 7 diopters, then let's say minus 2 diopters, and let's say then 5 diopters. So even negative is possible. Have an effective focal length. Have an effective focal length of how much? That is the question. Let's try and solve this. As we know that the powers get added and the focal length is the reciprocal of the power, and you add the reciprocal of focal lengths to get the effective focal length. That's what I showed you right over here. But here power is given, focal length is asked, so multiple ways of doing it. Either you find individual power and then find effective, or you find effective power and then find effective. I feel adding powers are easy, so stick to that. I can just say P1 plus P2 plus P3 will be P effective. So basically 7 diopters plus negative 2 diopters plus 5 diopters is the effective power. So therefore 7 minus 2 is 5, 5 plus 5 is 10. So 10 is basically the effective power, but power is nothing but 1 by F. So that is what it is. Therefore, the effective focal length is 1 by 10, which is 0.1 meter. If the options are in centimeters, 0.1 meter is nothing but 10 centimeters. So that's how you get the answer. Cool. Let's do the next question coming up on your screen. Imagine it's given to you that there is a lens, and this was asked multiple times in the JEE Mains examination in different ways. First time you are cutting the lens like this, okay, you are getting 2 parts, and the second time you are taking that same lens, but you are cutting it like this. Question is, you will get 2 parts, right? What is the focal length of each part? Assuming this particular lens had a focal length of f, what is the focal length of each part over here? Okay, that's the question. So what you do is, let's draw the both parts. How will it look like? Okay, so you can say something like this. So they will look like two plano-convex lenses, okay, being added to each other. So this is nothing but a combination of this and this. Similarly, I can think of this as, combination of this and this, and of course, just blacken this off. Yeah. This and this together makes this particular lens. Now you might be wondering, sir, should I use the same P1, P2 formula, F effective formula in both the cases? Well, let's think. When I divide it like this, visualize, if at all there were rays of light, if at all there were rays of light, they will pass through this lens also and get refracted. They will pass through this lens and get refracted. And that same ray will again pass through this lens and again get refracted. So refraction is happening 2 times. So refraction occurs 2 times. So I can say refraction. Are what it is? Something weird. Okay. So I'll say refraction occurs 2 times for the same ray. So it is basically, I can say, these are 2 thin plano-convex lenses. Plano-convex lenses which are in contact, which are basically in contact to give me the original lens, the original effective lens. So using the power formula or focal length formula, anything, 1 by new focal length plus 1 by new focal length is 1 by effective focal length, which was originally f. Therefore, I can say 2 times of f1 is basically 1 by f. Therefore, what will f1 be? F1, what will f1 be, guys? Think about it. 2 by f1. F1 will be nothing but 2 times of f. This is very interesting. Lot of people think the answer will be f by 2 and f by 2. That is absolutely wrong. In fact, it is the power which will get half. So if the original power was p, this power will be p by 2. This will be also p by 2, which will add together to give p. But the focal length will double. That's a common mistake which many kids have made. Hi, Hazu, hi me. Yes, CR7, all playlists of class 12 and class 11 chemistry. What are you saying? I don't think so. Yeah, it should be there. How is it possible? Class, guys, like the video, guys, if you've forgotten. Oh, where is it? It's class 12. Yo, okay, I understood. Some mistake has happened. Okay, I'll get it sorted, man. I'll get it sorted. Not an issue. Okay. Okay. No issues. All right. Great. Thank you, CR7, for pointing it out. Thank you. Thank you for pointing it out. Right. So now, having said that, what about this scenario? A lot of people think we can use the same concept here also, but that's wrong. See, the light ray which will go here, that's not the same light ray which will go over here. These light rays are completely different. What goes here and refracts here. So the refraction only happens once, but the refraction gets divided among two parts. Whatever rays go on the top are different from whatever rays go below. So only half of the rays are going from the top, half of the rays are going from below, but they will meet at the exact same point. Meaning, say for example, if the rays were going from below, after refraction over here, they were meeting here, the same thing will happen due to refraction here, and they will eventually meet here, making the image. So the image location does not change because you have cut it into two parts, or each part does not have different focal lengths. Rather, they have same focal length. So if the focal length was f, each part will have a focal length of f only. It's just that the intensity of light reduces. Intensity of light reduces because the number of rays which were originally passing would be more, as compared to just taking apart, only half of those rays will be passed. So that's why lesser rays, lesser intensity, lesser brightness. Got it? Okay. Everybody with me on this? Perfect. Great. Cool. Yeah. Shall we go ahead? Ritik, I hope this is clear now. Okay. In the first scenario, there were two plano-convex lenses. So one after the other, the rays got refracted. So it's like two plano-convex lenses are in contact. Here it is not the case. This part and this part, they have same focal length because the rays will refract identically. It's just that the number of rays get divided. So the brightness of the image will be less in each part if you separate them out. Okay. Namaste Abhinav. Perfecto. Now let's go to the next question coming up on your screen, and here it is. Let's see. A convex lens of certain focal length is placed in contact with a concave lens of focal length 20. Object is placed to the left of the lens system, the distance of the images. First of all, understand that when we have two lenses, I can replace it with one single lens. I can replace it with one single lens, which is the effective lens. So for that, let's look at it. Focal length of 30 centimeters and a concave lens of focal length 20 centimeters. So let me find 1 by f effective first, which will be 1 by f1 plus 1 by f2. If you talk about the convex lens, the focal lengths are always positive for convex lens, but for concave lens, the focal lengths are always negative. So this 30 is actually plus 30, but F2 is not plus 20, rather it is minus 20. Okay, anyways, the LCM is nothing but 60. This is 1 by 30 minus 1 by 20. So 60 and 30. 30 goes with 60 two times, 20 goes with 60 three times. So 2 minus 3, which will make it minus 1 by 60. That is F effective. Therefore, the effective focal length will be minus 60 centimeters. What does this mean? It means that the total combination behaves like a concave lens of 60 centimeters. This is your effective. This behaves like a concave lens of focal length 60 centimeters. If the answer was positive, effective combination will be a convex lens or converging. Now you take this effective lens, whatever it is. Now look at where that object is placed. I think the object is placed 20 centimeters. Yes, object is placed 20 centimeters. The focal length is minus 60. The question is, where is the image going to be formed? So 1 by V minus 1 by U is equal to 1 by F. V I do not know. Object distance standard is negative 20. It's on the negative side. Focal length is minus 60. So therefore, 1 by V will be equal to minus minus is plus. On the other side will again become minus. So minus 1 by 60 plus 1 by 20. I've just taken out the minus sign common on the right hand side. Okay, minus is common, LCM is 60. Okay, so 1 plus 3 basically, which is minus 4 by 60, which is minus 1 by 15, that is 1 by V. Therefore, the image distance will be minus 15 centimeters. Okay, so the image distance will be minus 15 centimeters. They just have asked the absolute distance. So the answer will be basically option number 4. Option number 4, 15 centimeters. No, it is not option A. It is option number D. Okay. Yes, perfect. Sir, do we have X-rays and radioactive decay activity concepts for mains? No. X-rays is not there. Radioactivity decays law is not there. But remember what is alpha ray, gamma ray, beta ray. That much you should know. Neutrino, antineutrino, that mass number change, mass atomic number change. Only that much part you should know. Radioactivity law, disintegration law is not there. Okay. Cool. Perfect. Let's move ahead to the next question. Wow, this was asked in JEE 2024. Huh? Let's see if you guys can solve this. As you can see, the curved surface of a plano-convex and a plano-concave. It looks like a glass slab if you look at it. But actually, that glass slab is made of two plano-convex and concave lens, arranged in a very peculiar way to look like a glass slab. But don't be fooled, inside part, there are two different refractive indices. So it will not exactly behave like a glass slab because inside part is not uniform. It is having two different mu's or refractive indices. Radius of curvature is perfectly matching. So they fix onto each other like a puzzle piece and find the ratio of the radius to the focal length of the combined lens. Okay, let's do one thing. First, let's find focal length of plano-convex, then plano-concave, and then add them together to get the effective focal length, because that is what the question is. If you ask me for the plano-convex lens, 1 by f1 will be lens maker formula. It is mu minus 1. Then if it is a flat surface, remember for a flat surface, the radius of curvature is infinity. So 1 by infinity for the first surface minus 1 by R2. This is the second surface. It is also on the negative side. As you can see, it is also on the negative side. Okay. So therefore, I will say it is minus R over here. So that will give me mu1 minus 1. This 1 by infinity is 0. Minus minus will become plus. So therefore, it will become mu1 minus 1 divided by R for the plano-convex. Similarly, for the plano-concave, 1 by f2 will be refractive index minus 1. The first surface is like this. The center will be here. The center is on the negative side. So the first radius of curvature will be negative. So 1 by minus r minus 1 by the second surface of the plano-concave lens is flat. So flat surface means infinite radius of curvature. Okay. So this will become mu2 minus 1. Okay. 1 by infinity is 0. So minus 1 by r plus 0 or minus 0, I can say minus 0. So minus is going that side. So it will become minus of mu2 minus 1, or you can also write it as 1 minus mu2, the whole thing divided by r. That is for plano concave. Now, if you take the total combination, 1 by f1 plus 1 by f2 is 1 by the total focal length. So, what is 1 by f1? It is nothing but mu1 minus 1 by r. What is 1 by f2? It is 1 minus mu2 divided by r. And this is nothing but 1 by f. So, minus 1 and plus 1 will cancel. So, we will have mu1 minus mu2. Mu1 minus mu2. 1 1 got cancelled. Denominator is same. Is 1 by f. They have asked the ratio of the radius to the focal length. So take r on the top. So mu1 minus mu2 is basically r divided by f. So mu1 minus mu2, that should be the answer right over here, which is option number 2. This was asked last year. Yeah, interesting question on the combination of lens coupled with lens maker formula. So don't just expect a singular concept questions in even in JEE Mains. Expect multiple concept questions, multiple formulas, because you cannot just be dependent on a singular topic. Okay. Hi Twinkle, hi Vinod. Yes, the option number 2 is absolutely correct, my dear students. Moving on now to the next part, where you have thin lenses or lenses not in contact, rather they are separated by some distance. Sir, is there like a simple, easy, super duper formula? No. Instead, you have to do it like this. Whenever the lenses are there, okay, with different focal lengths, multiple lenses, doesn't matter, but there is some separation, okay, which are not in contact. So what you do is, you use the lens formula. First time for the first lens, you will get the image. This image then becomes the object for the second refraction, and it will make the image next. If there is one more lens in front, Chumma, I am drawing it. It may be there, it may not be there, I don't know. If there is one more lens in the front, that image becomes the object for the third lens, and it will again make the final image. So this is the play in such problems. You will have to basically use lens or mirror. It could be a lens and a mirror also, guys. Lens and mirror formulas as many times as needed. Not just that, you have to also take care of the sign conventions, take care of the sign convention. Not just that, the most problematic thing in these problems is you might get the image distance, but the image distance is not object distance, because this image distance is measured from this lens. This object distance will be measured from this lens. When you get the image distance for this lens as I2, for I2, that image distance is different from the object distance from the next lens. So the object 3 is measured from the new lens. So that is something which you need to take care of. So also take care of the image and object distances. Take care of the image and the object distances. So these are the words of caution or methods by which you can get the solution. See, there is nothing much in theory. We have to go to the problem only to see actually how it is implemented. Okay, so let's see. Here is a nice question coming up on your screen. Sometimes the questions don't even need any formulas. I think this is one such question. The following diagram represents two biconvex lenses, L1 and L2, having a focal length of 10 centimeters and 15 centimeters. The distance between L1 and L2 is how much? The following diagram represents two lenses, but they are not in contact. Ray diagram is shown. That is very important. As you can see, the ray is parallel, that means the object is at infinity. Here also the ray is parallel, that means the final image is also very, very far away. Okay. How can this happen? This can only happen in one scenario where what should happen? This ray will obviously meet at the focal point of this lens, and if the ray has to become parallel, this should also be the focal point of the next lens. That means this should be focal length 1 and this should be focal length 2. What is focal length 1? Already mentioned as 10. Focal length 2 already mentioned as 15. So if you ask me what is the total distance, it will be 10 plus 15, which is nothing but 25 centimeters, which is option number 3. Got it? Everybody with me on this? Perfecto? Clear? Understood? Yes? No? Perfect? Very nice. Very good. Great, guys. This can be also sometimes asked with, let's say, even mirrors also. Like, say, for example, this kind of question. I'll just tell you how. Maybe they can tell you that you you have you have a mirror like this, and then you have a lens over here like this, and then you have a parallel beam of light, and it is told to you that after all the refractions, whatever happen, the beam retraces back the same path. Okay, and you might be told some focal length is there, some focal length of this lens is example 20 centimeters, focal length of this lens is, let's say, 30 centimeters chumma. So how is this possible that the beam is nothing but retracing the same path? Okay, so in this problem you have to think, if it has to retrace the same path, somehow for the mirror the object should be at the center of curvature, or the ray should pass through the center of curvature, because that is the only ray on a mirror which retraces the path. Now, second thing, if the rays are parallel on the lens, 100% after refraction it should pass through the focal point. So first of all, let's say or assume this is the focal point of that particular lens. Then what will happen after the refraction? The ray should pass through the focal length, but that focal length should be such that it should be the center of curvature also of the lens. It should be the center of curvature of the mirror. Only then the rays will retrace back through the center of curvature, and any ray which passes through the focal point of the lens will become parallel. So this is the only way this can happen. So this means if this is the focal point for this lens, this should be nothing but 20 centimeters. This is center of curvature, that means this should be radius of curvature. R is nothing but 2f. So 2 into focal length, which is 2 into 30, which is 60 centimeters. So naturally, this complete length will be 20 plus 60, which is nothing but 80 centimeters. So such a question can also come for mirrors with lenses also. How many of you understood this concept? Okay, this is very common type of question in your JEE examination. Okay, find the distance between mirror lens, find, if the distance is given, find focal length, or how will you place it so that the rays are again as it is, or retracing, or parallel. Okay, common question. Everybody like these questions? Smash the like button right away right now. Okay, so let's go now to an amazing question which was asked in JEE 2021. Find the distance where the image will be formed by the combination of the lenses. First is a convex lens, focal length plus 10. Next is a concave, so minus 10. Next is convex, so plus 30. Distance between the lenses are also given. That means you cannot combine as a single lens as of now. Okay. First object is 30 centimeters away. Now this problem has to be done in parts. So let me just duplicate this. Forget the other lenses. Just focus your attention. Just focus your attention on this particular lens for now. Nothing else. Just this particular lens. As you can see, the object distance is 30 centimeter. I will locate where the image is formed. Okay, observe it carefully. Just focus on that lens, nothing else. So 1 by V minus 1 by U is equal to 1 by F. V I do not know. Object distance is negatively 30. Focal length being a convex lens is positive 10. So 1 by V will be minus minus will be plus, goes on the other side as again a negative sign. So 1 by 10 minus 1 by 30. The LCM is 30. 10 goes with 33 times, 1 remains as it is. So it will become just 2 by 30, which is 1 by 15. But remember that is 1 by V. So V will be positive 15 centimeters. So positive 15 means where? Somewhere over here. Actually 5 plus 10, that means on this lens. So this is where my first image is formed at a distance of 15 centimeters from the first lens. But like I said, don't say this is the final image. This is an intermediate image. This image will act like an object for the next lens. Okay. Now, again, I will redraw the scenario. Observe carefully. Now your focus should be only on this particular lens, the middle one, because that is the next one through which the rays will go. Now, whatever this image was will be the object. Yep, the rays are coming, but it will be a virtual object. Don't think the rays are going like this. No, the rays are actually coming like this. So this is still the positive side. This is still the negative side. And from this new lens, the object is at a distance of 10 centimeters. The object is at a distance of plus 10 centimeters. Everybody got it? I'll just repeat. The first image we just saw was 15 centimeters from the first lens. This is 5, this is 10. So the image is formed here. But that image will be the object for the next lens. If you want to visualize the ray diagram, it will look something like this. The ray will go like that and it will go like this. But actually it can't go straight because this lens is coming in between. So technically this will be a dotted line. Are you getting my point? Okay. The ray can't go through the lens perfectly like that because it will get refracted in between. So that image will now become an object and it will refract and make an again a new image. So let's use lens formula again. So 1 by V, I do not know V, minus 1 by U, object distance is positively 10, is equal to 1 by focal length is minus 10 because it's a concave lens. So 1 by V will be minus becomes plus, 1 by 10 minus 1 by 10. Wow, this is becoming 0. Don't be scared. V will be actually infinity. What does V becoming infinity tell you? What does V becoming infinity tell you? It tells that, listen boss, see the ray came like this, I agree. The ray refracted like this, but it wasn't able to go till here. Yeah, it wasn't really able to go till here because it got refracted in between like that. But after the refraction at this particular point, what happened? The ray turned such that the image is formed at infinity, meaning the ray just went like this. The ray just went like this. Yes, it just continued its journey like this. Is this absolutely clear, my dear warriors? The ray is just going like this, parallel to the principal axis. How many of you understood till this point? Yeah. Now, yes, Mohan Ram, I will just look into that playlist. I will just take care of it. I'll just inform the team tomorrow. Okay. Tonight, nothing can happen, but tomorrow things can happen. Now, if the rays become parallel, what will happen after refraction? They have to meet at the focus to finally make our final image. to make our final image. And this will be nothing but 30 centimeters, because this is nothing but the focus. This is nothing but the focus. But the question is, how far is it formed from the object? This is 30, this is 5, this is 10, this is 30. 30 plus 30, 60, 60 plus 10, 70, 70 plus 5, 75. So this entire distance is 30 plus 5 plus 10 plus 30, which is 75 centimeters, which is option number 1. Perfect. So this was asked last year. So you can see how nicely they can frame the questions. Yeah. Okay, everyone, loved the question? This is how you solve the questions of combination of lenses. Now, I think I have kept a homework question also for all of you. Try this out. This was asked in 2019. This also is a fact that, after 5 years or 4 years or 3 years, suddenly the question models will get repeated. Like, look at this model. Object is there, two lenses are there. This was asked in 2019. Now, back in 2024 or 2021, you can see after 2 years, suddenly they have asked a similar kind of question. So models keep getting repeated. Even in 2025, this kind of questions were asked. So try this out, because you have solved the previous one. This is actually much easier. In fact, we solved for 3 lenses. This is just 2 lenses. So just apply lens formula 2 times, you will get the answer. Okay. So will you be able to do it? Yes or no? Yes, Sarvesh, Nitish, Abhinav, Mohan, Vinod, everyone, Sidhu. Yeah, I think you should be able to easily do it, because they are just 2 lenses. Okay. Put the answers in the comment section. The answer and the solution will be also there in the PDF after the session is over. The link will be there in the description box and in the comments. Now comes the last part, which is silvering of lenses. This is where again many people get confused, but I'll keep it very easy and I'll explain it in such a way that you will remember it rather than by hearting weird things. Silvering lenses, meaning you just have one lens. That is the worst part. There are not multiple lenses, just one lens is there. But one part of it, you have painted it with silver, meaning you have polished it so that it becomes like a reflector. So the ray which enters inside the lens, it hits the silvered surface, rebounds, and again refracts through the lens before making the final image. So this is the fascinating part, where there is a mirror involved along with the lens, but in contact. But don't worry, such a combination, a silvered lens, always always acts always acts like a mirror. effectively Effectively speaking, it always acts like a mirror, because the ray which enters eventually is coming back. Yeah, refraction might happen, but it is coming back. No, if it is coming back, it is reflection. So it is some kind of a mirror, convex, concave, I don't know, but it is a mirror. So if you analyze what exactly is happening, here it is. Observe now carefully. We have a lens, and I'm saying that I am basically silvering this surface. This is a silvered lens. This is a silvered lens. This is actually made up of, I can say, a lens, then again a lens, and then a mirror. Some of you might be wondering, why the hell am I talking like this? Why am I saying 2 lenses and a mirror? This, and this together makes this silvered lens. This also can be effectively, like I said, at the end of the day, everything behaves like a mirror, convex or concave. So it will behave like a new mirror. I don't know what the curvature might be. So Chumma, I put a new mirror. This is your effective mirror, some kind of mirror. So this is just a mirror This is that particular lens, that same lens again. Why am I distributing it as two lenses and a mirror? See, look at the ray diagram, things will be obvious. A ray which enters, a ray which enters this system will refract, reflect, refract before finally coming out. Don't you see that? How many of you are able to see it? A ray which enters inside refracts, reflects, refracts before finally coming outside. This is object, this is image. So refraction is occurring two times, like once while entering inside the lens, then it hits the mirror, then it again passes through the lens and again then comes out. So after reflection, it is again passing through the lens. That is why you have to consider the lens two times. That is the crux of the problem. Many people forget to take the lens two times. They think it's just a lens and a mirror. Wrong. It's not just a lens with a mirror. It is a lens, then a mirror, and again a lens because the ray is coming out again through the lens while exiting. Is this possible? Is it possible to get dispersion in curved lenses? Obviously, Abhirami, dispersion occurs every single time, whether it's a lens or a plain uh, glass slab, doesn't matter, right? Okay, we'll be talking about dispersion in the next lecture. Anyways, prisms. So that is the reason of this. And now these are basically two lenses and a mirror in contact. And what do you do when lenses, mirrors are in contacts? I just opened up my session with that theory today. Whenever you have lenses, mirrors, etc. in contact, you just add their powers. It's nothing great. So in this particular question too, all you have to do is power of this lens plus power of this mirror plus power of this lens is equal to the effective power of that particular mirror. So therefore, it is 2 times PL plus PM is effective power of the mirror. What is the power of a lens? It is nothing but 1 by FL. Yeah. What is the power of a mirror? Remember, it is minus 1 by F. For lens, it is plus. For mirror, it is negative. I explained that in mirrors lecture. This is also a mirror. So the power should be negative. So minus 1 by F because it's a mirror. Now, if you want, you can take that minus sign inside. So this will become 1 by Fm minus 2 by Fl is nothing but 1 by F effective. This is the formula. You start with this formula. It will be very easy. Else, you will have to start with the basics then, where power plus power plus power is the effective power. This is also okay to be an opening statement, but quite lengthy. Why do you want to do these 3-4 steps? Skip those steps in the exam. So 1 by Fm minus 2 by Fl is 1 by F effective. Use this formula, your job is done. If you forget the formula, start from the basics. Okay? Is this okay? Clear? Shall we do a question on this so that you understand? Okay? So let's start. Let's start doing some questions on this. Let's take that same lens only. I think great. Okay. Let's say the refractive index is 1.5. Let's say this particular radius of curvature is 20 centimeters. And let's say this particular radius of curvature is 30 centimeters. Okay. Question is, find the effective focal length. Find the effective focal length. First of all, here is what I will do. I'll just treat it as a lens with 20 centimeter and 30 centimeter radius and the refractive index 1.5, but this will be two times a lens added with added with just a simple concave mirror whose radius will be 30 centimeters. Okay, I know at the end of the day, it will behave like a new mirror whose focal length I do not know. That is what I have to find at the end of the day. Okay, let's start. First, for the mirror, very easy. Guys, this is radius. What is the focal length? There is a formula. Don't use lens maker formula. Yeah, this is a mirror, right? R is 2f. R is 2f. So basically, 30 is nothing but 2 times the focal length of the mirror. But please keep in mind the sign. The sign of the radius is negative because it's on the negative side. So therefore, the focal length of the mirror is minus 15 centimeters. Is nothing but minus 15 centimeters negative because it is concave. Okay, that part is done. Now let's look at this part. For this, I have to use lens maker formula, no other option. Refractive index is 1.5, so minus 1. 1 by R1. This is the first surface, the radius is on the positive side, so positive 20 minus 1 by R2. R2 is on the negative side, so minus 30. Yeah, this is negative side, this is positive side. 1.5 minus 1 is 0.5 multiplied by this minus minus becomes plus. So LCM is 60, 3 times and 2 times. 0.5 is nothing but half multiplied by this is 5 divided by 60. 5 goes with 60 12 times. So this will be nothing but 1 by 24 is 1 by FL. Okay, I think I'm okay with just FL, or if you want, FL will be 24 centimeters. Now I will go to my original formula. 1 by F effective. Remember, 1 by F effective. This was our formula. Where did it go? Yeah. 1 by F effective is 1 by FM minus 2 by FL. 1 by FM minus 2 by FL. Use this formula over here. 1 by FM minus 2 by FL. So what is this going to be? FM is nothing but minus 15. Use the signs, don't skip the signs. Minus 2 by FL. FL is plus 24. So this will be minus minus is common. 1 by 15 plus 1 by 12. Is that right? 1 by 15 plus 1 by 12. Okay. What is their LCM, my dear students? I think we have to just multiply, no other option, right? So 15 into 12, 15 tens are 150, 15 11s are 165, and 12s are nothing but 180. So this will be just nothing but 180. This will be nothing but 15 plus 12, of course. So that is going to be minus 27 by 180. Yeah. If you want, you can just cut them out a little bit. 27 goes with 3 times 9. 27 is nothing but 9 into 3. So this also will go 3 times. Yeah, this will become nothing but 16. This will be further divisible by 3. This is 3. This is further divisible. That will be 20. So minus 3 by 20. Therefore, I get the value of my effective focal length. It is nothing but minus 20 by 3 centimeters. That is my answer. Minus 20 by 3 centimeters. Got it? Yeah, 6.67 negative, negative because it's a effective concave mirror. So it's nothing but concave as expected. It is a concave mirror as expected. Cool? Great. Let's solve another nice question coming up on your screen. Imagine this. There is a plano concave mirror. Refractive index mu is 1.8. Radius of curvature 40 centimeters. Question is as follows. The object is placed here. The object is placed here. Okay. I want to know this particular distance. I want to know this particular distance such that no image is formed. such that no image is basically formed, such that no particular image is formed. That's the question. Okay, let's try this out. How do we do it? Okay, or you can, yeah, this kind of question, or images coinciding. So that kind of question can also come. Okay, find the distance such that the image coincides with the object. Okay, that kind of question. Or they can just tell you, listen, boss, the object distance is only given. Maybe it is given as 20 centimeters. Then they will ask you, where is the image formed? Any kind of question can come. Doesn't matter. All the models will always start by converting this into a single mirror as it is. Okay. Now this system, okay, let's just solve this particular problem and see where it leads to. This particular problem is nothing but a combination of this particular plano concave lens 2 times and a plane mirror. This is just a plane mirror, and this is plano concave lens. This completely will behave like, most likely it's diverging in nature, so it will be a diverging mirror. So it will be a diverging mirror, something like this. This is your effective mirror. Okay, this you should be able to predict easily, because if it's a concave lenses are diverging in nature, so final mirror will also be diverging in nature. Okay, so let's think. I have an idea now. I don't think I'll go by the traditional route, because this is a plane mirror, and I got a very interesting idea now. Rather than going by the traditional way, okay, I feel I know what a mirror does. I know what a mirror does. A mirror, basically, plane mirror, reflects whatever is there in the front, it replicates it behind it. So, if there was a plano concave lens, same thing will be replicated behind of it, like this. Oh, now it will become a equiconcave lens. And all that has been possible because the mirror has replicated whatever was in the front. I have replicated it over here, isn't it? Now this looks like an easy question to me, because I can easily find the focal length of that lens. Refractive index is 1.8 minus 1. 1 by R1, R1 is negative 40, minus 1 by R2. The second radius will be here. First radius was here. This was the second radius, so it will be plus 40. This will be nothing but 0.8. Minus will come outside. Okay, multiplied by minus 2 divided by 40. Okay, this goes like this. This will be 8 by 10 multiplied by minus 1 by 20. Okay, 8 goes with 20. How many times? Divided by 4 is 2. Divided by 4 is 5. This 2. This will become 5. So this will become minus 1 by 5 5s are 25. So the focal length of that lens will become minus 25 centimeters. This is behaving like a lens now of 25 centimeters concave lens. So what do we do now? Hi Santosh. Imagine our object is over here. Object distance is given as 20 centimeters, but it is on the negative side. Question is where the image will be formed. So use lens formula. 1 by V minus 1 by U. U is minus 20 is 1 by focal length. Focal length is negative 25. Therefore 1 by V. This minus will become plus. On the other side will again become minus. So 1 by 25 plus 1 by 20. Negative sign I have taken out common. Okay. So the LCM will be 100. 25 goes with 100 4 times. 20 goes 5 times. So this will be minus 9 by 100 is nothing but 1 by V. Therefore, image distance is minus 100 by 9 centimeters. 100 by 9 centimeters. So I have located where the image will be formed at a distance of minus 100 by 9. Now, what is the meaning of minus 100 by 9? Minus 100 by 9 means somewhere here. This is somewhere where the image will be formed. This distance is basically minus 100 by 9. This is the most common mistake which now kids will do. People will say the image is formed on the left side at 100 by 9. That is wrong. That is wrong. Do not forget, when we solved the entire problem, our opening premise was, because this is a plane mirror, whatever is there in the front will be reflected back. I should close my book. If I've opened my book, I should close the book back. So the moment I close this in the front will go again behind. So for this particular combination, actual image will be over here at a distance of 100 by 9. This is the crux of the problem. Lot of people are going to say left side, but there will be options saying right side, which will give you positive marks. How many of you understood the trick of the question? Yeah. So when I did from this to this, okay, whatever was there in the front, I replicated it behind. So when I close this chapter, obviously whatever was there in the front will also go at the back, because everything, this whole world will tilt. Okay, it will be flipped. Yeah. Is that absolutely clear? Shreyas Srinivas, oh my God, wow, you have taken my name only or what? Yeah, so one more class, prisms and dispersion. Okay, just one more class to go. Okay, that is tomorrow. Great. Let's do another question which was asked in 2025 itself. Beautiful question. Let's see. Given is a thin convex lens, each side having some radius, one side is polished. At what distance from the lens an object be placed so that the image gets formed on the object itself? See, this kind of question, like I told you. So you have a plano convex lens where one side is silvered. I know this is nothing but the lens which will come 2 times and a mirror which will effectively become just a simple mirror. So this plus this, and this is nothing but your effective mirror. Okay, so let's start finding out each and every term over here. First, let's start for the lens. 1 by FL will be refractive index is mu minus 1. Both the surfaces have same radius, so 1 by R minus 1 by minus R. So this will become mu minus 1 multiplied by, this will become 2 by R. So it will become 2 into mu minus 1 divided by R is 1 by FL. Next thing, for the mirror, we know radius is nothing but 2 times of the focal length. So focal length for the mirror, but this radius itself is negative, because for the concave mirror, this side will be negative, that side will be positive. So therefore, we get the value of Fm as minus R by 2. That being done, let's use the effective formula. 1 by F effective is 1 by Fm minus 2 by FL. 2 by FL. Okay, what is 1 by Fm? Fm is minus R by 2. So minus R by 2 minus 2 by FL. 1 by FL is already given, so I'll just use that. So 2 is there, and now as it is, I will put it over here. So multiplied by 2 into mu minus 1, whole thing divided by R. Okay, so as I can see, 2 goes on the top, and this will become basically minus 2 by R minus 4 mu minus 1 divided by R. So this will become minus 2 minus 4 mu, minus minus is plus, plus 4 divided by R, which will make it 4 minus 2 is 2. So 2 minus 4 mu divided by R, which is 2 into 1 minus 2 mu divided by R, which is 1 by F effective. Therefore, F effective will be r divided by 2 into 1 minus 2 mu. Till this point, absolutely clear? Yeah, till this point, absolutely clear? Okay, perfect. Okay, Vanisha, school from Tamil Nadu. Oh, you're from Tamil Nadu. Welcome. We are like old brothers only then. Yeah, because I was also born in Tamil Nadu from Salem. Yeah, I'm from Salem, Tamil Nadu. All right. Now, having said that, don't go by my looks. I don't look like I am from Tamil Nadu. Don't ask me why. Same way, you can say Kalki also. Kalki Cochin also doesn't look from Tamil Nadu, but she's from Pondicherry, right? Yeah. So, having said this, uh, yeah, what was our original question? Where should you place the object so that the image is formed on the object itself? This can only happen if the object and image are at the same place if it is the center of curvature, at the center of curvature. So that particular distance, is radius, and radius effectively will be 2 times f magnitude wise. But how much is 2 times of this? So 2 into r divided by 2 into 1 minus 2 mu. So that will be r divided by 1 minus 2 mu. So this is nothing but that particular distance. So r by 1 minus 2 mu, r by 1 minus 2 mu. Actually, this is a negative answer. So when I take the distance part, when I take the mod, because this number is bigger than this number, so 2 mu minus 1 will come to keep the answer positive. So that's why 2 mu minus 1 will come if you actually find the distance. Right now, this is just the radius. So if I'm wondering how much is this distance, that particular distance will be actually minus r. And when I do minus of this, which is minus of r by 1 minus 2 mu, that will be r divided by 2 mu minus 1, which is the fourth option over here. This was asked this year. So you better prepare yourself, guys. The question levels are good, as you can see. It's not a singular step. Lens maker formula, mirror formula, okay, over here, mirror concept, then again effective combination of lenses, then again going back to mirrors, taking care of signs, so many things, all things to be done really quick. So these are the levels of questions which are asked. Three, the PDF will be available in the description box, bro. See over here, where is it? So you go to any video like this, okay, description box. Can you see over here? Also in the comment section, you just open this, click this link, the PDF will open. If it asks you for a sign up, create your free account. If you already have a Vedantu ID, use that ID. It's absolutely free of cost because it is on our Vedantu servers. Okay, it is always there. Even after 1 year you come, it is there. Or else I put it on some random places, Telegram here, there, it will vanish. Okay, that was the answer. And that was the last question. So we have completed lens combination, lenses in contact, and silvering of lenses, which are, some high level questions, and they are asked like I showed you over here. So if you like the video, please do that because it's very important for you to show your support, and subscribe to the Vedantu JEE English channel because you have seen that I always give you that quality content, and we'll start from the basics and scale you up. By the way, a big surprise is coming this weekend, and a game will change. Things are going to change. We have to level up because barely 100 days are remaining. And now is the time where a massive change will happen on the YouTube channel. Okay, so be ready for that. Be prepared. See you very soon. Bye bye. Take care. This was your Captain Shreyas.